So how do you prove this identity? When you have 2 minus open bracket sine theta minus cos theta close bracket, the squared is equivalent to what? Sine theta plus cos theta all squared. Now how do you prove this identity? So now our focus is to actually solve this to look like this. So we'll be focusing on this expression on the right hand side. So let's solve this systematically. So what do you have? You have what? 2 minus, now you have this expression squared, it becomes what? Sine theta minus cos theta, sine theta minus cos theta, because it is squared. So let's expand the bracket. So it becomes 2 minus sine theta times sine theta is sine square theta. Sine theta times minus cos theta is minus sine theta cos theta. Minus cos theta times sine theta is what? Minus sine theta cos theta. Then minus cos theta times minus cos theta, minus times minus will give you what? Plus. Then the cos theta multiplied by cos theta will give you what? Cos square theta. You close your bracket. So let's simplify the expression in the bracket. So you have 2 minus sine square theta, then minus sine theta cos theta minus sine theta cos theta will give you what? Minus 2 sine theta cos theta. Just like minus a or minus ab minus ab minus 2ab. So that's the same thing we used here. Then we have what? Cos square theta. Now what can we do? Now you can have something like this, 2 minus, now I'll bring this cos square theta together with this, it becomes sine square theta plus cos square theta minus 2 sine theta cos theta. Now if you recall from trigonometry, sine square theta plus cos square theta is equals to 1. So I substitute 1 for this expression here. So it becomes 2 minus what? 1 minus 2 sine theta cos theta. Now I can expand the bracket. So it becomes what? 2 minus, now minus 1, minus times 1 is minus 1. So minus times minus 2 sine theta cos theta will give you plus 2 sine theta cos theta. Then 2 minus 1 is what? 1 plus 2 sine theta cos theta. Now we have arrived at this expression. This is how far we can go from here. But we are told that we should prove that this expression is identical to this. But this is our answer. So how can we convert this to this? It means we can go further. Now remember that sine theta plus cos theta is equals to 1. So let's bring back this equation and substitute it for 1. So what do you have? You have what? Sine square theta plus cos square theta. That is for your 1 now. You have substituted it for 1. Then plus 2 sine theta cos theta. Now what do you do? Let's rearrange it in the form of a quadratic expression. It becomes sine square theta plus cos squared, plus 2 sine theta cos theta plus cos square theta. Now how do we simplify this? There's an easy way we can do it. We can use algebraic expression to simplify it. What do? We say let sine theta be equals to a and what? Cos theta be equals to b. So we can write this expression in terms of a and b. So what do we have? So sine theta equals to a. So sine square theta is what? A square plus 2 sine theta cos theta will be what? 2ab plus what? Cos square theta plus b square. Now we can factorize. Is that okay? We can factorize. So it becomes what? If we multiply a square and b square, it's going to give us a square b square. Now what are the factors that when we add them it gives us 2ab And when we multiply them, it gives us a square and b square. Both of them are what? ab and what? ab. So we can substitute this for 2ab. It becomes what? A square plus ab plus ab plus b square. Now, let's consider these two expressions. You can see that a is common. It becomes what? A into a plus b. Plus, if you consider these two expressions, b is common. It becomes b into a plus b. So what do you have? If you factorize it, you have a plus b into a plus b. So both of them are common or the same expression. You can combine them. It becomes a plus b squared. Now what is your a? Sine theta. Plus what is your b? Cos theta. Then what? Squared. So you can see we have finally proven that this expression on the left hand side equals the expression on the right hand side.